Welcome back. So in the last video, we talked about conditional statements and rewriting regular sentences so that they have a condition to them. If something happens, then there's a result. Okay? And then we looked at the vocabulary of hypothesis and conclusion. My hypothesis is everything between if and then, and my conclusion is everything after. And I need to make sure I don't use words like it and they in my conclusion when I write it separately, okay, or in my hypothesis ever. Let's look at one example using a math equation. My conditional statement is if x plus 7 equals 10, then x equals 3. So my hypothesis, again, is everything between if and then, not including if and not including then. My hypothesis is x plus 7 equals 10. What's my conclusion? Everything that comes after then. In this case, it's x equals 3. Okay? Remember when we did inductive reasoning the other day, we said a counterexample is a specific example that proves a conjecture false. And it could be a set of numbers, it could be a sentence, it could be a drawing. Anything that proves something to be false is considered a counterexample. Okay? We use counterexamples also to prove conditional statements false. So here I've given you a false conditional statement. If two numbers are odd, then their sum is odd. Remember, sum means adding together, right? So we want to first identify the hypothesis. So your hypothesis is everything between if and then, not including if, not including then. Two numbers are odd is my hypothesis. Okay, then we're going to identify the conclusion. Everything after the word then. Their sum is odd. If I just write their sum is odd, I don't have an accurate subject. I don't know what there is. What were we adding together? We were adding together, look at the subject from the first one, we were adding together two numbers. So then, their sum is odd. The numbers, right? The two numbers have a sum that is odd. The two numbers have a sum that is odd. Okay? So then I want a counterexample. So let's see. I need to start, the hypothesis needs to be met, and then we need to disprove the conclusion. This needs to be false. So the first part will be true, but the second part needs to be false for this to be a counterexample. So let's pick two odd numbers. I don't know, let's see, an odd number, let's go with 5. And let's add another odd number, because I've got two odd numbers. How about 9? Do they have a sum that is odd? Well, 5 plus 9 is 14, so that happens to not be odd. 14 is even, right? So this disproves my conclusion on this conditional statement. So this is a perfectly acceptable counterexample. Is that the only one I could have given? No. There's a whole bunch I could have given. I could have picked any two odd numbers, 7 and 13, right? Because that would be 20, which is even. So any two odd numbers will actually give you a sum that is even. So any two odd numbers you pick would be a great counterexample. Okay? Let's look at a couple of practice problems. It says finish the following conditional statement so that it will always be true. If an angle is named angle ABC, then what are we going to know is true about that angle? We don't know anything about its size. If I just know it's angle ABC, I don't know if it's obtuse or acute or right or reflex or straight. I don't know anything about its size. But I do know if that letter B is in the middle, when the letter B is in the middle, I know that has to be the vertex, right? So I can have my condition, my hypothesis, or my conclusion to this hypothesis be if an angle is named angle ABC, then the angle has a vertex of B, right? So I don't have to say then the angle, right? Because the angle is already in the sentence. If an angle is named angle ABC, then the angle, has a vertex at point B. Okay? I could also talk about its sides, right? I could say ray BA is one of its sides, ray BC is one of its sides. So there's a couple things you could do there, but you can't say anything about its actual size, right? We don't know if it's acute or right or obtuse or straight or reflex, but I do know it for sure has a vertex at B. Okay? When I look at the next one, write a true conditional statement that has the conclusion, the angles share a vertex. Okay, so I need to try to think of types of angles that share a vertex. Okay, well, I remember when I think of adjacent angles, I know the definition is two angles that share a vertex and also share a ray that don't overlap, right? They share this ray, so here's an angle and here's an angle, but look, they share that vertex. So I could go with my adjacent angle, the first angle relationship we learned, because they do have to share a vertex. I could also go with a linear pair, right, because they are adjacent angles that are supplementary. So a linear pair would work. I could even do vertical angles that are across from each other. They don't share sides, but they do share a vertex. But I'm just going to go with this first one that I thought of. I'm going to go with adjacent angles. So I want my conditional statement to have this as the conclusion. So I'm going to start with if angles are adjacent, then, and my conclusion is the angles share a vertex. But since I've already used the angles up here, I can use they right here. If angles are adjacent, then they share a vertex. Okay, let's look at number 4. On number 4, write the definition of collinear points as a conditional statement. So do we remember what collinear points are? Remember, co means together and linear means line. So those are going to be points that are together on a line. So I just drew some collinear points, right? So I can say if points are collinear, then where are they at? They're all on the same line. If points are collinear, then they lie on the same line. Okay? Let's look at this last little bit that it wants us to do. It says for number 7, determine the validity of each conditional statement. If false, give a counterexample. So let's talk about that word validity and what we mean when we see the word validity. Okay? Validity, think about the rest. It's saying determine this if it's false. So what's the other option? If it's not false, that means it must be true, right? When it says determine the validity, it's saying determine whether or not the statement is valid, which means is it true or is it false? So determine the validity is just another way of saying this is a true, false situation or question, okay? So if it's false, we're then going to give a counterexample. Okay, so let's look at the first one. If you have $5, then you have 5 $1 bills. Do you think that's true or do you think it's false? Okay. So if I have $5, I must have 5 $1 bills. So 1 and 2 and 3 and 4 and 5 $1 bills, right? Is there any other way I could have $5? Well, yeah, right? I could have just one $5 bill, right? Instead of this, I could have one $5 bill. I don't know why I made it bigger. All the money's the same size, right? So the validity of this statement, if you have $5, then you have 5 $1 bills. This is a false statement. Okay? Since I said it's false, that means I need to give a counterexample. I'm going to say I could have one $5 bill. Okay. Look at B. B says if I roll 2 6-sided dice and the sum of the numbers is 11, then one die must be a 5. Okay, so let's think about the way we can get, well, let's first, in case you need review, right? A 6-sided die has 1, 2, 3, 4, 5, and 6 on it, right? So my sum, I'm rolling 2 die, so I'm going to get 2 numbers. My sum is 11. Well, how are ways that I can add the numbers 1 through 6 and get 11, right? So the only ways to get 11 would be 1 plus 10, or 2 plus 9, or 3 plus 8, or 4 plus 7, or 5 plus 6, okay? But I don't have a 10 on the die. I don't have a 9 on the die. I don't have an 8 on the die. I don't have a 7 on the die. So the only thing I can roll, I can either roll a 5 on the first die and a 6 on the second die, or vice versa, right? I could roll a 6 on the first die and then a 5 on the second die. But either way, one die is going to have to be a 5. So the validity of this statement is true. It is a valid statement. Okay? All right, this is the last one for today. If 2 angles are supplementary, then one of the angles is acute. Okay? So normally when I draw supplementary angles, a lot of times I'll draw them as a linear pair because I know on one side of a line I have 180 degrees. And usually when I draw them just like this. But now this proves my statement, right? One of these angles is acute. I want to see, is there a way I could draw this where one of these angles is not acute, right? Here I've got an acute with an obtuse. But what are my other angle options other than acute and obtuse? Well, I could be straight, but that would take up the whole angle, and I wouldn't have 2 angles. I'd only have the one if I wanted to stay supplementary. My other option would be, what if I went straight up perpendicularly and hit at a 90? Well, then I'd have 90 on this side, and I'd also have 90 on this side. So it would be 2 angles that would be supplementary because they'd add up to 180. But neither one of these angles is acute. So this is not a counterexample. This one is a counterexample. And this statement is false. One of the angles does not have to be an acute angle because I could have 2 right angles. Okay? Now, I could write that out. I could write false. Both angles could be right. And so I've got my validity and my counterexample. Or I could put my validity and then just draw this picture. This picture is in and of itself a counterexample. So counterexamples don't have to be sentences. They could be pictures. Okay? All right. Hopefully this helps you with conditional statements and using counterexamples to prove or disprove conditional statements. All right. Thank you so much for watching.